Good evening. What we have today is atomic structure. So we need to understand the concept of the atom. So an atom is regarded as the smallest particle of a material, of a substance, which can take part in a chemical reaction. It does not exist on its own. So it comprises of the proton, neutron, and the electron. The proton is the positively charged particle. Electron is the negatively charged particle. And neutron has no charge, so it is nil. The mass of the proton is 1 AMU. Mass of the neutron is 1 AMU. Then mass of the electron is negligible, which is 1 all over 1840 AMU, approximately 0. So the mass of the atom actually is the mass of the nucleus. The nucleus consists of the proton, the neutron, positron, antiproton. Okay? So the nucleus consists of proton, neutron, positron, and these are bounded by what we call the nuclear what? Force. What does that mean? The proton, neutron, positron, which is found in the nucleus, is bounded by nuclear force. Now, what do we mean by a neutral atom? A neutral atom is an atom that is electrically what? Neutral. The number of proton equals the number of electron. Okay? So when we talk about a neutral atom, a neutral atom has equal number of proton and neutron, and proton and electron. Okay? Then if an atom is represented as X, A is atomic mass, Z is proton number or atomic number. A is atomic mass, Z is atomic number, where N is the difference between the atomic mass and atomic what? Number. The number of proton and neutron, the sum of proton and neutron is equal to the nucleon of an atom. The nucleon number is equal to proton plus neutron, which is the nuclear number. How will you get neutron? N is equal to A minus Z. That is how you get neutron. Okay, so we have what we call models of an atom. Okay, the plum pudding model was proposed by J.J. Thomson in 1897. The model described the atom as having the mixture of positive and negative charges. The mixture of positive and negative charges called the plum pudding. Plum pudding. Plum in a pudding. The plum is the negative charges, then the pudding is just the surface. Pudding is the positive charge. Okay? Though Thomson's model failed because it could not explain the experimental evidence of the scattering of alpha particles by the atom. Okay, so that was the problem of Thomson. He couldn't explain the experimental evidence of the alpha scattering particles. So Rutherford came to his rescue. Rutherford's model solved the problem of Thomson. Thomson couldn't show, account for the alpha scattering experiment. Okay, but in Rutherford's experiment, he was able to solve that problem. Rutherford, in his alpha particles scattering experiment in 1911, discovered the positive nucleus and the electrons orbiting it under electrostatic attraction. okay, he was able to discover that, an atom has a central core, a central, a positive central core, and electron revolves about the positive central core. The force of attraction between the electron and the proton, because he said that the positive central core, okay, the central positive core, whatever that is inside here, is a positively charged particle and attracts electron, okay, and that electron moves with the speed of light. In this case, he was unable to account for why electron did not fall inside the nucleus, because if it is attracted by a positively charged it is attracted by a positively charged particle inside the nucleus, it should have the ability to fall inside it, but he was unable to account for that. So Niels Bohr solved the problem of so Niels Bohr solved the problems of Rutherford. Niels Bohr in 1913 was able to solve the problem of Rutherford using quantum theory and emission line spectra of hydrogen atom. So, since Rutherford said that the atom has a spherical shape, okay, electron revolves around the nucleus, the positively charged particle, and there is force of attraction between the positively charged particle and the electron. Niels Bohr looked at it and was able to account for why electron couldn't fall into the nucleus. And what did he say? He said that electron, yes, revolves around the core, but the shape of the atom should be in concentric circle, in the sense it will be this form, that electron resides in each energy level, okay. Then this is the orbit. Orbit 1 is n equal to 1, n equal to 2, orbit 2, n equal to 3, orbit 3. So using quantum theory, he was able to know that, to say that electron possess energy, that electron possess energy in each energy level, okay, that the energy that electron possess, E, is equal to NHF, okay. This is the energy electron possess. So he was able to account for the reason why, because this energy cannot be emitted so long as is residing in this discontinuous region. So that was exactly what Niels Bohr said. So long as you are in energy level 2, you can use this formula to calculate for it. If you are in energy level 1, you can calculate for it. Energy level 3. So there is no absorption of energy or liberation of energy if electrons are not moving from one energy level to another. So this occurs, there is absorption or liberation if there is what we call excitation or de-excitation of electrons. So because electron possess a particular energy in its energy level, it cannot fall into the nucleus. So it has solved the problem of Rutherford. And he also used emission light spectra, where we have different light spectrum. Hydrogen has different series, hydrogen series, okay? So and it can be seen in different region, all right? So the series of hydrogen atom are 1, Lyman series. Hydrogen atom has what we call Lyman series, okay? Lyman series. The next one it has is Balmer series. Balmer series. The next one it has is Paschen series. Then next one is bracket. Next one is P-Fund. Okay, these are the series. They have 5 series, and these series are seen in different region. The Lyman series is seen under ultraviolet region. The Balmer series is seen under visible region. The Paschen series, bracket series, and P-Fund series are both seen under infrared region. So this, he explained the atom using the series, using the emission line spectrum of hydrogen atom. Okay, so from here we shall move to how the orbit has velocity, the velocity of the electron in the orbit. According to Niels Bohr, let us see how the velocity of the electron in the orbit is proved. Now, we have the nucleus, which consists of the positron, the atom, the proton, the neutron, okay, and electron revolves around it. Electron is a negatively charged particle. Positron is a positive electron, okay, while proton is Z. So this E here is positron, and it is found in the nucleus. This E is positive, okay, positive electron is found in the nucleus, and it is called positron. Z is proton, it is also found in the nucleus. This proton, okay, attracts this electron, and because of the electrostatic force of attraction between this nucleus and the electron, it caused centripetal force to be generated, so that it will keep the electron revolving about the nucleus. So we have what we call the electrostatic force of attraction, which is equal to centripetal force, so that this can continue without falling out. Now, according to Niels Bohr, that ZE, okay, multiplied by A, the negative sign is coming from this side, okay, all over 4 pi epsilon naught r squared equal to mv squared over r, so that the negative side cancel out negative. We have ze squared over 4 pi epsilon naught r squared, which is equal to mv squared over r. Then we have that mv squared is equal to, okay, 4 pi epsilon naught r squared, crossing and multiplying is r ze squared. So this cancels this, okay, making v squared solid of formula. We have ze squared over m 4 pi epsilon naught r, so that the velocity of electron in the orbit becomes square root of ze squared over m 4 pi epsilon naught r. Okay, dash is the velocity of the electron in the orbit. Bohr's radius. Okay, the question says show that Rn equal to epsilon naught h squared n squared over pi m z e squared. What will you do? The L here is called angular momentum. Angular momentum is linear momentum times radius. Okay, and this is the integral multiple of Planck's constant nh over 2 pi. So according to Niels Bohr, that mvr of the electron, angular momentum of the electron, is equal to nh all over what? 2 pi. We've already derived the velocity of the electron in the orbit. So the angular momentum of the electron in that same orbit is equal to mvr, which is equal to nh all over what? 2 pi. So from the other equation, we also say that Fe is equal to Fc, which we have as minus z squared over 4 pi epsilon naught r squared equal to mv squared over r. This cancel this, this cancel this. So we make v squared the subject of formula. So we now have v squared equal to ze squared all over 4 pi epsilon naught mr. Okay, we call this equation 1. Then from here, mvr equal to nh over 2 pi. Square both sides. Square both sides. So we have m squared v squared r squared equal to n squared h squared over 4 pi squared. Okay, so we can easily make v squared subject of formula, which is equal to n squared h squared all over 4 pi squared, okay, m squared r squared, equation 2. So equating the two equations, we cross and multiply such that 4 pi, one of it, we cancel this, m, we cancel one of the m, okay, then we have ze squared, okay, r squared, okay, then pi m equal to n squared h squared epsilon naught r. So to make r, sorry, from the one of this we cancel this, we now have r is equal to, in terms of n, because this is rn, r is equal to n squared h squared epsilon naught over z squared pi m. Okay, z squared pi m, n squared h squared epsilon naught. Okay, so this becomes rn. So in this case, this is the radius of the atom. Okay, it is called the radius of the atom. I know the atom has orbit. So if this is the radius of the atom, for the first orbit, when n is equal to 1, we have r1 equal to h squared epsilon naught ze squared pi m. To prove the kinetic energy of the electron in nth orbit, to show the kinetic energy of the electron in nth orbit, we go again. Fe is equal to Fc. Okay, from here we have that minus ze squared all over 4 pi epsilon naught r squared is equal to minus mv squared all over what? R. So this cancel out this, and one of these cancel this, making mv squared the subject formula. We have mv squared is equal to ze squared over 4 pi epsilon naught r. So what do we do here? We need kinetic energy is half mv squared. So to introduce 1 over 2 here, we need to introduce 2 over 2 mv squared, such that when you introduce 2 over 2, nothing has actually happened because 2 can cancel out 2. But because we need 1 over 2 from here, we take these 2 down, cross and multiply it. And then we now have that 1 all over 2 mv squared is equal to z 8. 2 times 4 is 8 pi epsilon naught r. So the kinetic energy of the electron is equal to Ze squared over 8 pi epsilon naught r, according to Niels Bohr. So to show the total energy of electron in the orbit, first we talk about the kinetic energy. Kinetic energy has been proved. Then potential energy. Potential energy is equal to negative Ze squared over 4 pi epsilon naught r. So this is potential energy, and kinetic energy Ze squared over 8 pi epsilon naught r. So total energy is equal to kinetic energy plus potential energy, and K is equal to Z squared over 8 pi epsilon naught minus Z squared over 4 pi epsilon naught. Okay, so this will give us LCM is 8 pi epsilon naught r, then 8 into 8, 1 times z naught is Z squared minus 8 into 4, 2z squared. So 1 minus 2z squared, we have E, that is the total, E total is equal to minus Z squared all over 8 pi epsilon naught r. So that is the total energy. To find the energy of the electron in nth orbit, En, after getting the total energy, we have it as En equal to minus Z squared over 8 pi epsilon naught Rn. So Rn is n squared h squared epsilon naught pi over pi mz squared. So what do? We just substitute this value here. We remove it and replace everything here so that we'll be able to get minus Z squared. So when you put it in, you will have 8 pi, okay, then n squared h squared epsilon naught. Instead of writing divide by, it will come up pi m, okay, pi mz squared. So that we have minus z squared E4, okay, pi cancel out pi, what else again, m, right, divide by 8 epsilon naught squared, n squared, then h squared. So from here, we'll say, therefore, En equal to minus Z squared over n squared into, okay, E4 m all over 8 epsilon naught squared h squared. So Using the usual parameters, E is charge, which is 1.6 times 10 raised to the power minus 19 coulomb. Okay. Then M is mass. Mass is 9.1 times 10 raised to the power minus 31 kg. Then epsilon naught is 8.85 times 10 raised to the power minus 12. Then H is constant, 6.6 times 10 raised to the power minus 34. So when you put in these values, substitute them into this place, we shall get En is equal to minus Z squared over N squared into 13.6 electron volt. Okay, so Z is equal to 1 for hydrogen atom. So this is what we have as for the energy possessed by the electron in nth orbit. Alright, to calculate the energy that will raise an electron from its ground state to first excited state if the wavelength of the transition is 6.0 times 10 raised to the power minus 7 meters. This question is the number one question under atomic structure. So how do we go about that? You see, calculate the energy that we raise. That means energy change from ground state to first to excited what? State. So the formula is energy change is equal to HF. Okay, and H is Planck's constant, F is speed of light all over wavelength. Now we know that H is 6.6 times 10 raised to the power minus 34, then C is equal to 3 times 10 raised to the power 8, and we're given the wavelength as 6.0 times 10 raised to the power minus 7 meters. Okay, so the energy change, energy to raise is just E naught is ground state. Let E naught be ground state, and E1 is first excited state. First excited state. So E1 minus E naught is equal to HC over lambda, which is 6.6 times 10 raised to the power 34 multiplied by 3 times 10 raised to the power 8 over 6 times 10 raised to the power minus 7. So E1 minus E naught is equal to 3.3 times 10 raised to the power minus 19 joules. To calculate the energy of a photon of wavelength of 3 times 10 raised to the power minus 8 is just the same as asking you to calculate the energy released. Okay, so energy released, during transition is called photon. Okay, energy of a photon. So we have change in E is equal to, or energy of a photon is equal to HF, which is equal to HC over lambda. We're given H. H is Planck's constant. Okay, Planck's constant. Then 3 times 10 raised to the power 8 over 3 times 10 raised to the power minus 8. So to find the energy of the photon, which is 6 times 10 raised to the power minus 18 joules. So how do we state the energy level of hydrogen atom? Number one, we have the ground state and the excited state. Okay, we have first energy level, second energy level, third energy level, fourth energy level, and the first energy level is the ground state. Okay, so calculate the energy required to excite a hydrogen atom from its ground state to the second excited state. Second excited state. When n is equal to 1 is the ground state. When n is greater than 1, excited state. Second excited state is when n is equal to 3. First excited state is when n is equal to 2. But now they said second excited state. So we are not talking about when n is equal to 2, but we are talking about the second excited state when n is equal to 3. So when n is equal to 1 is the first energy level, which is the ground state. So En is equal to minus 13.6 over n squared electron volt. So we can easily find E1, which is minus 13.6 electron volt. Then E3, which is minus 13.6 all over 9. Okay, so 13.6 divided by 9 will give us 1.51 electron volt. So we have calculated the energy E1 and E3. F is equal to changing E all over H. Okay, this is electron volt. And the 1 electron volt is equal to 1.6 times 10 to the power minus 19 joule. So frequency is E3 minus E1 all over H. And E3 minus E1 from what we have calculated for minus 13 minus 1.51 minus 13.6. We multiply it by 1.6 times 10 to the power minus 19 divided by 6.6 times 10 to the power minus 30. F is 2.93 times 10 to the power 15 Hertz.
If you like the video, subscribe to my channel and click on the notification bell. Thank you.